I finally got my first client for a 3D printing project.
Yay!
The client is actually my girlfriend, but the task at hand is not an easy one. So let's take a look what I have to work with. So the client asked me to design a storage box for these knitting needles. My first thought when I saw the amount of the needles was, well, this is going to be a challenge. And a proper challenge it was. What was supposed to be a fast project turned into a journey that would take several weeks to finish. So let's see how this happened. The first step of any good project is proper planning, and I like to draw some sketches on a paper. Usually the sketches might not make much sense to others, but it's just a process for me that helps to come up with new ideas. Before starting the project, you should also list the requirements of the project. You know, the size, functionality, colors and things like that. And this project had only a few requirements. The box should have a knitting theme, needles should be sorted by size, and colors should be soft and nice, whatever that means. So with these requirements I came up with the most complex plan as possible. So the basic idea of the box is to make a modular system where you can take out different modules that contain different sized needles. The problem is I don't really know how to do this idea. But I guess it's still better just to start designing the parts, starting from the locking mechanism. The box is going to use compliant mechanism for the locking, and the basic idea that I came up with was to make a 3D printed spring that can easily be pushed down and lock the box in place. There are also several standard ways to do locking boxes, like over-center mechanism, but my idea is a bit unique, so I think I will have to do some experiments. First I played around with these S-shaped pieces to see if they could be used for a lock. A simple compliant mechanism. Sadly, nothing in 3D printing is simple for me. It first felt like it could work, but I later found out better shape that I could use. The zigzag shape is much better suited for push buttons. Once again, this would have been obvious if I had done some research. I hate to admit it, but there is always someone who has already come up with better ideas than my failed experiments. This shape was also not without problems. Some of the buttons would not hold out well when printed with PLA, but after the experiments I found the perfect solution. So this zigzag pattern turned out to be pretty good for the push buttons. The zigzag locks will be used to lock the needles in their modules. So this one here is also a failed prototype. But the basic idea is that one module can contain 15 needles and have a lock for each set of the needles. After locking in the design, it was time to print the modules. I had to print 5 different sized modules for the needle case. In total the case will have space for 80 different sized needles and some extra space for spare needles. And each module will have their own needle locks to keep things in place. The needle locks are made of 2 different parts, and they are also printed in 2 parts. If you are wondering why it's printed in separate pieces, that is because I wanted to ensure the best quality for the spring mechanism, and both parts can be printed without supports with this design. The spring mechanism is printed straight to the build plate for the best layer orientation and maximum strength of the part. The lid part will hide the spring mechanism and at the same time improve the overall look of the box, while also having the function of showing what sized needles are behind the lock. I also tried my best to make the modules as thin as possible. This case certainly will not be the most space efficient, but it will still do what it was meant to do. I certainly seem to have the habit of over-engineering these storage solutions, but I also like to explore the different mechanical solutions for these boxes. I wonder if there is a line where the product is too over-engineered. Anyway, now I'm ready to move on to the box design. So now I have made the modules, but I still need to make the box. But the rest of the model should probably be pretty easy to make. I started looking at different knitting designs. I need a cool looking pattern for the box. And for the pattern design, I settled for this loop design. I thought it would be a cool design to make and a proper challenge.
A few hours later.
What is this design? This feels practically impossible to make. But what should I do? How do I do the impossible? Do you know what the answer is for seemingly impossible task? Just don't give up. And I did not give up. I discovered the intersection curve tool that allowed me to sweep through this problem. A task once seemed impossible was behind me. It's time to print and finally put this project to an end. Okay, let's assemble the box. Don't tell me it is so. I triple checked the measurements. How is it possible it does not fit? It turns out my measurements were right. It's just that I did not print the right part with the proper measurements. And I really hate the feeling of messing up a 7-hour print. But I guess I can use this box for something else. Okay, let's try again. Okay, so now the modules fit in nicely and I can add the side panels to the box. They are supposed to be really tight fit, so there's always a chance that something goes wrong here too. The knitting patterns on the panels turned out pretty nice. The 3D printing can't fully capture the complex patterns, but if it looks okay, who cares? Okay, here comes the scary part. Let's see if the side panels will fit. As expected, they are extremely tight. Don't you love a good fit? Well, it's in there, but there's a small gap. Well, that's a tight fit for sure. Last like it's almost good, but well, maybe I should have done some more thinking again. It's like it's almost good, but it's a freaking balloon box. Maybe with glue and clamping this could be fixed, but still feels like a stupid mistake. Should have just left the better tolerances. After sleeping overnight thinking about my problem, I came up with pretty nice solution for my box problem. My first idea was to press down the sides with weight to see if I could flatten out the box, but that didn't quite work out. So I came up with another idea, and that idea was to make a simple collar for the box, and the collar should be able to press down the sides enough. So let's see if this idea works out. The solution came out pretty good, so all that is left is the grand reveal. Enjoy! Well, this project certainly was a handful. It sometimes felt like the box just refused to be perfect, and there are still some issues with the box, but it came out pretty good. That's it for now. Bye!